Um, so yeah, what we're going to do now is basically walk through our line balancing module and the features and some of the new features that we've added. Um, and along with me, uh, we have our developer Arul, who's going to be talking about those new features. Uh, so right off right at the start, what I want to get into is what line balancing is in Proplanner and what the basic philosophy is, and then I'll hand it over to Arul to talk about the new features. So for those who have used Proplanner or are looking to use Proplanner, just a basic introduction of what line balancing is. For those who have used the system probably know this, but I'll just walk through it quickly. As you know, our software is oriented around the process, the manufacturing process. And key to that process is what we call an activity. Activity is, the smallest amount of work that I would move between operators, right? Anything lower than an activity would be like a time study element. So it's the smallest amount of work that I would move between operators. And what we do after creating the activity in Proplanner is we map multiple data elements to it, right? As Lindsay was saying earlier, we do time studies, be it Moda apps, calculated or observed time studies are just your best guess. We allow you to have a time element tied to the activity. We map parts to the activity so that we know what's happening, as was being discussed in the 3D discussion earlier. From the parts, we know what models the activity is being called for. We map tools, we map ergonomic decisions or movements on the activity. We can create control plans and FMEAs from the activity. And finally, we create work instructions out of that activity. So the activity is heavily loaded in Proplanner. It's key to our process plan in general. And one of the reasons that it's so useful to do line balancing or moving activities between operators is because we move all of that information with the activity. So as you reassign work between stations and operators, all of that information moves with it, right? So as you can see here in the line balancing chart, we take these activities, we align them by station, by operator, and then the line balancing allows you to manually move work or has algorithms built in that move the work for you automatically. And that's the basic philosophy behind line balancing. You can see down below, we are showing that as you move this information around, we are able to create all this rolled up data for you, be it routings, BOM, costing, work instructions, control plans, a set of consumed parts, and so on, right? So that's the basic idea behind line balancing is, we're moving activities and we are creating all this information for it. Right? So line balancing, the UI, if you can go, the user interface in Proplanner, it shows a bar graph at the top that shows for each station or operator the work content. It's fairly easy to use. You can drag and drop activities between stations. You can also use our automated algorithms that move the activities for you. We show you violations if you move activities around, be it violations in the sequence of or the order in which you're doing the activities, what we call the precedence violation, be it a violation of tools that are missing at the station where you move the activity to, or zones zones meaning the area, there's a missing area in the station that you cannot perform the activity at. So all of those are features that are built into the tool. We show you that as the activities move around. You can create a view for just a standard stacked bar graph showing you the activities and the total time at the station. What Arul is showing here is a view of the Moda at a station. So the red, green, and yellow show you the non-value added, value added, and semi-value added content at a station. And then most importantly, the line balancing supports mixed model line balancing. So we allow the user to create a line balance for multiple models or mixed models. And then at each station, we are able to compute the average work being performed across all those models that are going down the line. And some depending on the rules of the company, some folks go with the average being less than takt time. Others have a representative model that they want to keep below takt time and so on. But all of those capabilities of a mixed model line balancing are available in the tool. I think that's where the benefits are. This is the same view that Arul was showing earlier, but now instead of a simple rolled up bar graph, we're showing you a stacked bar graph. At each station, this is the work by model. So the blue is one model, and that pink is another model, and then the dotted bar is the average at each station. And then the other thing that you can do here is for each of those tiles that you see in the Yamazumi graph that we're showing here, you're able to click through each of the tiles and get details about all of the content of that activity. So what I was showing you earlier, you can look at what models is this activity for, what options, what's the time, what steps are involved in this activity, what tools does this activity need, what parts, and so on, and even watch a video or look at images tied to that activity. This is a great tool for the shop floor users. If you have a group of users who contribute from the shop floor, who contribute to your line balance, who are involved in moving activities around, this Yamazumi view is very popular in those settings. I think a lot of companies do these with a board with magnets on it, where they move these bars around. It's exactly trying to mimic that functionality, but it's a lot more informative, because each of these tiles has all this information behind it that the user can simply click on and review the details for. So before you move your work, you can get the full analysis of what's happening. You have your tack drawn right there to show you the impact of moving that around. It'll push your average up and down. And then also, and as I was mentioning earlier, you can switch this just simple stacked view to a Moda view to see what happens if I move work around. Does my non-value added content at a station go up or down, and so on. So, very easy way of interacting with the balance and moving things around. Finally, before I hand it over to Arul, just a little more about line balancing and the algorithms that I was talking about earlier. We have three major algorithms. Minimizing number of stations. So basically, you give it a tack time, and the system tries to compute the least number of stations required to do a balance. Minimizing cycle time, which is where you give us a number of stations, and the system tries to tell you the most optimal tack time that you should be running the line for. Last one is minimizing the number of operators, where you're not really moving work between stations because you have a constraint. You can't really add stations or remove stations. So your work at each of the stations is pretty much fixed. You are trying to have the system compute the number of operators and shared operators between stations for a given tack time. So those are three constraints, those three algorithms that we have built into the system. You can see we have multiple constraints also in the system. We respect if you group tasks together, if you have work zones that I was saying, I have a wall coming up on the line, so I cannot do any work on the left side of the line, or this is the only area where I can work under the vehicle. So those are what we call work zones. Monumental resources, hoists, things that flip the unit upside down, those are only fixed at certain points on the line. I cannot have that work move anywhere, so be respectful of that when moving activities, and so on, right? So these are constraints that we can add to the line balance to get a more accurate result before we move work around. And you can see that the tool tries to tell you of all the possible errors that can, not errors, I guess, violations that can come up as you try to rebalance the line for attack time. You might not have enough stations, you might not have enough operators, you might be violating monuments, you might be violating zones, and so on. All of that comes up as you try to run the balance. It's very interactive. It lets you go back in and out of the balance as you tweak things around. One of the most important things in line balancing is precedence. That's essentially the order in which the activities occur on the line. As we went through this process with multiple customers, we realized that defining precedence is a challenge. If you have a small set of activities, maybe you can still manage to do the precedence and connect them all together and in the right order that they must occur. But if you have thousands of activities, maintaining that graph is a significant challenge. So we took that input from the customers and we added a feature called clustering in the software, and we'll get into that here and show you how that works. The other thing that we've added in line balancing is accounting for times that do not have any Moda classification. With a lot of these audits in the plants where folks are trying to eliminate non-value add, improve reduce non-value added costs on the line, we saw that there were a lot of activities that were missing Moda classifications or had incomplete Moda classifications. So, for example, if I had a 2-minute activity, only 1 minute was accounted for in Moda. So we added a feature in line balancing to show that to the user. So not only am I showing you value add, non-value add, semi-value add, and idle time, which are all critical for Moda analysis, I'm also showing you that, hey, you are missing a lot of the time. You haven't accounted for a lot of the time under Moda, and so your losses are higher or lower because you still don't know the true picture here. So with that, I'll ask Errol to go in and show those two features, clusters and tracking unclassified time. And then at the end, we can go into some more line balancing discussions and questions. So,
right. Thanks, Abhishek. And yeah, as Abhishek said, precedence is one of our non-optional and key constraints that we take into consideration when creating a line balancing scenario. So this line balancing scenario that I've created from a routing that has precedence defined. So let's take a look at that routing first. So the first thing you want to do when you want to define precedence is navigate to your routing and then navigate to your precedence tab. So there are two main ways of defining precedence. One is in the sheet view and one is in the graph view. And many of you who are familiar with using Microsoft Project for defining precedence earlier would remember how this works, but the idea is same. You just define your predecessors and the successors are automatically calculated here, but you just give your predecessor row IDs and define your precedence that way. And the second way is to do it in the graph where you have all your activities as nodes in the graph, and then you just link task to a different task. So in this example, there are around 20 activities that I've defined, and defining precedence for this is simple. But however, in a realistic routing, that what we have seen from some of our customers is that this could range anywhere from 500 to, and in some cases, like thousands of activities. And defining precedence for each of these activities, to and from each of these activities, is going to be a difficult task. So the new feature addresses that, and also also in some cases we may not know the entire sequence. Let's say this, you may know that the first these 5 activities come before the next 5 activities, but you may not necessarily know the sequence within those 5 or so activities. So that's where the new feature clusters will come in handy. So there are 3 main ways of defining cluster. So let me just wipe out my precedence that I've created. So the first way of defining clusters is by just typing a cluster ID. Just gonna say, and good feature that we have is this is exactly like Excel. You can just drag, drop, and copy the values onto an Excel. So that's the first and simplest way of defining clusters. And the next is to just select a bunch of activities and right click and say add to cluster. And here you'll be presented with a new UI where you can put those activities into an existing cluster if you have one, like how I created one right now, or you can create a new cluster for them. I'm going to say door. And you can add more activities to this if you decide to, and that's where we have had this UI. And if you are familiar with using advanced search, this is exactly the same UI. where the routing and routing type now is fixed. You can search, you can add activities from different routings, but you can filter the activities within this routing. So once you have results, you can select your bunch of activities from this advanced filter form and then add those selection. Um, and you can also select and remove some of the activities that you decide. But for now, I'm just going to add these to the second cluster. And now this is a new view that we have added as part of the clusters feature. And this is also a way of creating new clusters. So this will list all the clusters that you have created, as well as it will also let you create new clusters in this UI. And it not just that, it will also give other key cluster related parameters in this view. You can put a cluster description, sequence number, and sequence number will be taken into account when you're doing default precedence um, in the graphical view. And also you can have clusters inside clusters, which I'll explain in a moment, and also link clusters to different activities or different clusters. And one other feature that we have added is like how we have color coding for the graphical activity nodes. We have also added color coding for the cluster nodes. So I'm just going to create a new cluster here. I'm going to name it, going to hit save. So now this cluster does not have any activities yet. So you can just select an edit cluster and you will be presented with the same form that we used in the first sheet view. And then similar to that, you can just add activities from here. All right, now the last is the graph view. So now here in the graph view, you can also create new clusters by just selecting the task nodes that you want to create a cluster for, and then right click and say add to cluster. So I'm gonna name this, what did I name? And I'm gonna say final assembly 2. All right. So now we have 4 clusters. Now, if you do want to see the activity nodes within each cluster, you can select that cluster you want to look at and then say expand cluster. You can also expand and collapse all the clusters at the same time if you want. And that's again will bring you this cluster crowded view, which is not very helpful. So there might be cases where you just want to group all these activities into a cluster and just focus on one at a time. So that's where you should be able to select the cluster there. All right, I'm just going to collapse all clusters. And the next big feature that we have is dragging and dropping. So once you have defined clusters, you can just drag drop activities from inside and outside clusters. And to define precedence, you can just define a link, precedence link, like how you define between activities. You can define it from cluster to activity node, and also from activities within that cluster. So that's pretty much the ways in which you can define precedence and how clusters will help you with doing with creating the precedence. And one more thing is like when you move the activities from inside and outside cluster in the precedence view, as well as in line balancing and Yamasumi chart, like Dave and Abhishek pointed out, uh, like uh, when you're moving them, you're moving everything that relates to activity along with it, like the model mappings, option mappings, work steps, resources, and consumption and videos if you have any. So that's one of the biggest advantages of using Proplanner as assembly planner, where even if you move your activities uh, across stations, across clusters, or across um, stations, you don't lose your data. And once you have made all your precedence related changes, you can go back to the line balancing scenario using line balancing scenarios tab. And you can just open the scenario, just view the Yamasumi chart, or run some reports from here. And this will this brings to the next new feature that Abhishek pointed out. So we have added the ability to show unclassified Moda times. So previously we had a VA, NVA, SVA, and idle and setup times, but we have added unclassified time as its own category. So what we have observed from our clients is that not all of them define Moda categories for the entire portion of the task time. So, and they would, in most cases, would want to view them as its own category. So now in the line balancing chart, as well as in the Yamazumi view, you would now see new category for those unclassified times. That was fast. That was an overview of some of the new features and enhancements. If you want me to dive deeper into any of the particular features that I've discussed, or if you have any questions in general about line balancing, you can let me know.
Thanks, Arul. It doesn't look like we have any hands raised right now. Does anyone have any questions? Or if you do, please just do the hand raise and we'll get to you. All right, Dave, you should be able to go ahead.
Yes. So, Arul, I was wondering if you or Bano could just show a few things related to, the Yamazumi view. I know that we have, as you can see on the interface, we have the different chart types and different color coding types. So it might be good just to kind of provide an example. I know there's a lot of questions about filtering and whether I'm showing the color coding and whether it's model average or not. Maybe you could just give us a quick overview of some of those options, because some of those have changed this past year.
Right. Yeah, so the one of the features that Dave just pointed out is both in the Yamazumi as well as a line balancing chart. You can see all the models at the simultaneously at the same time. And also with regards to color coding, you can see I have selected here the NBA Moda classification summary, but you can choose to not have any color coding, any specific color coding, and because I had selected two models, that's a default color coding that you're going to see. Or you can choose different color coding based on the classification, task sorted classifications, and also time sorted classifications. And also you have work zones, like if you have multiple work zones within a station, then those color coding will be different for that cases. Other than that, yeah, so you can filter or view multiple models at the same time and multiple options at the same time. Right now, this example doesn't do a good job in showing that, but yeah, so these are the ways in which you can change it in the Yamazumi view, as well as when you come to the actual line balancing chart view, you can change, by default, you're going to see all your stations, but you can switch to operators view. So like in this case, I have 2 operators per station, and now I have 6 bars, and you can move activities from across from across these categories. You can change the chart view type as well as the sheet view type. So to do that, you just have to select a station or operator in the sheet view, and then you choose your station that you want to focus at. You can also double click on the bar that you're looking at to go to that particular station's tasks. And as you all know, like to change an assignment, you can just drag and drop your activities into a different station, and you would be presented with this view where it would specify you which station you're moving the tasks to, what tasks you have selected, and what are the constraints you may or may not be violating. Did that cover the question, Dave?
Yeah, if you could go back to the view that you were just on, I think it might be a good idea that the conflict view where you drag a station or a task from one station to another, and you get the potential conflicts of that. I think that this is something that we've added. I can't remember if it was 2020 or maybe even a year or two before that, but it's been enhanced where, given the fact that there are so many possible constraints, especially as we add additional ones over time, there's a lot to be considered before you commit to a change. So I think it's important to note that this is for people that are new to line balancing, this is a way for the operator, the engineer, to essentially see, hey, if I make this change, here are the potential problems it can cause. And we never want to restrict an engineer from making a change, even if it violates some rules, but we want to at least inform them, of the impact of that change. I think the other thing to note too, if you could go back to the Yamazumi view where you were looking at the ability to filter by model. Okay, if you could just pull that down. So one of the things that we're seeing people do, a lot of questions, especially in automotive, has been when I'm doing my line balance, I want to look at my worst case model and I want to look at my best case, easiest model. Worst case being largest work content, easiest being smallest work content. But I also want to look at a representative model. And so I think what's important in line balancing for people to understand is that those models we're bringing in, those can be generated obviously in our order file, which is really before line balancing, where you can create actual customer orders. So you could generate a model with a set of options representing a customer order, representing the most complicated possible order, the easiest possible order, and the average most likely order. And by importing just those three models into this line balancing mode, we'll be able to generate all three of those possible scenarios: worst case, easiest case, and expected case side by side. So for those companies where the engineers are trying to figure out, how is this station going to be impacted when we see our most complex model, how's the station going to be, how much extra time is that operator going to have with the easiest model? And over time, what is the most expected model? Obviously, as you mentioned, Arul, the software is computing what we would call a probabilistic average model. That's those shaded bar always in the line balancing view. But a probabilistic average model, is obviously generated based on some sort of a percentage of model mix that we're expecting on any given production schedule. That's what we're seeing in this shaded bar there on the right. But once again, that may or may not really be representative, because of course, what's probabilistically going to happen is based upon a particular week, not a particular design concept, as in this is the worst case product, this is the easiest product. So I just wanted to kind of highlight that some of that filtering that we see now at the top in the Yamazumi chart view, some of those filtering options have been changed in the last, let's say, 12 to 24 months in terms of what you can do. And we're probably looking at additional capabilities there as we bring in the capability for people to, once again, quickly look at from a design perspective on this assembly line, how flexible is this line at accommodating this kind of product mix? All right, well, if there aren't any additional questions, I know we're getting close to our next presentation. So thanks a lot, Arul and Bondo, on the line balancing details.